Hi everybody, welcome to our new video. Today we're going to talk about electricity. So somebody asked me, what is the difference between DC and AC current? So we're talking about some simple physics here. I'm not good in physics, but some things I know, basics of electricity I know. So DC is direct current and AC is alternating current. So simply means DC, I would say, let me get you something here. Maybe I can show you something on the book. I guess you can see. DC current goes one way. You get me? They go one way. So since they go one way, we can get positive here and the negative here. So they can go one way, passing through the maybe electric light here. You understand? But DC, but AC, it can go quickly this side and quickly this side and rotate. It rotates back and forth. It can go this side a bit, like coming like this, alternating like this a bit, but quicker. It moves quicker, faster. So and also someone asked, okay, if you say that this is direct current and AC is direct and is alternating what current, can a 12 voltage be a DC or AC? Yes, this has nothing to do with this or this. We can have 12 volt direct current and also 12 voltage, which is alternating current. You understand? So yes, DC can be what? Can be 12 volt, and also AC can be 12 volt, right? So okay. Then I was hit with another question saying that, okay, we understand that. So tell me, do my charger, cell phone charger, use DC or AC? The question is very simple. Get your charger and check it here. I want us to check. It's gonna show us. I'm not getting it right here. I want you guys to see. Oh, I almost got it. Yes, you can see that it tells us input is from 100 to 240 voltage. Yes, 650 or 6 hertz. So those means 60 Hz means 60 times per second. You understand, right? So if you understand that, that's super good. But then you can see that the output is a 5.0 DC. You get me? So this simply means this charger takes in AC and converts to DC. So because a cell phone is using direct current, we have devices which uses direct current. There are many, like your TV, flat screens. You can get your cell phones, your computers and stuff. Okay, then that is understandable. I'm saying this is a very, 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 very broad topic, because if someone is going to ask you question by question. Why? Because it's a little bit complicated. But then someone asked again that, can we find a device which uses DC and AC at the same time? Yes, we can. And we then ask you which type of a device. Okay, you know your home washing machine is like this, right? This is your washing machine. I'm not good at drawing, but then it has some controllers here. The buttons here, Maybe this is a start. This is where you program to see water levels and stuff like that. Okay. Once you have that, that simply means that you're gonna do what you need to control. So this the controller, this controller has a motherboard. When you press here, which moves the water, whatever, then it gives a screen for time. You get me? So this entire board, which controls the machine, it's using direct current. Then there is a motor here, electric motor here. It looks sometimes like this, okay, and like this, like this, like this. This motor here, it's a spinner, so it spins when you want to dry up or when you want to wash and all that. This uses a AC. Do you understand? So this is one of the best example of machines which uses DC and AC is your washing machine. So I gave him that answer. You understand? So now the day cannot end there. You get me? So because someone's gonna ask you and ask you and ask you and ask you and ask you. You get me? So then there are many things you have to learn when it comes to electricity. Someone's gonna ask you about watts. Somebody's gonna ask you about MPT, AMP, amps, then amps. Okay, let me explain this. 1 amp column per second. That's it means 1 amp means 1 column per second. You get me? So the word is written like this: is COULOM per second. Okay, this is what they call 1 amp. They write it like this: 1A MP equals to, this is what you get, right? So then if you say that, then somebody's going to ask you this term. What is this term mean? Okay, this is going to be, okay, you said this is 1 amp equals to 1 whatever. So this was something like a French guy who discovered this this physics. So it's called amp-watt. So but they made it a little bit small to make it amp, but it was the name of a person anyway. So he's a physician anyway. So from, I think, France, somewhere there. So this 1 amp equals to 1 column per second. So somebody's going to ask you this. What is this? So that, which is going to be column, you can pronounce this the way you want. Okay, what is that then? It's going to ask you that, because the more you explain, the more you get questions, because you're going to come up with terms which someone doesn't understand. You get me? So that means, so someone is going to ask you that, then they're going to say, how do you measure this? So you can say it can be that 1 column. Remember, this 1 amp equals to 1 column per second, right? But this 1 columns, it's going to be, they call it's equivalent to 6 quintillion 242 quadrillion. Okay, quadrillion, yes, I'm getting you there. So that is something we're gonna write, which is gonna be very, very difficult if you don't know numbers here. So some things, get the basics, but if you want to learn physics of about electricity, you're gonna have to learn all that. So it's a 1 amp equals to 6 4 2 4 comma 0 0 0 times 1, 0 0 0 times 2, 0 0 0 times 3, 0 0 0 times 4, 0 0 0 0 times 5. 1 2 3 4 5, right? 1 2 3 4 5. Yes. Okay, that's what we have. That's what it means. So so now when we explain the amp is going to be amp, the amp. Okay, they say the quantity tells you how much electricity is being drawn through the power cable. Say that's where they say, okay, 1 amp, 2 amps. You get me? Those, I think they show those on some devices. You get me? So they say the quantity tells you how much electricity is being drawn through the power cable. Understand? So a product that draws 10 amps sucks twice as much electricity as a product that draws 5 amps. You understand? So that shows what the quantity which is being drawn into the power cable, right? So some things I'm going to explain them well, some they won't be 100%, but what brought us here, it was the DC and AC. But the topic keeps on growing and growing and growing and growing. You get me? So what you have to know that most of small devices, they use DC. Especially devices in your homes, you get me? They use DC. These big transformers you see, electricity you see on the streets, which are traveling from maybe from different country to another country, those it's being taken, like it's being, that is what they call it. Always it's a AC. You understand? It's very powerful. You get me? So that electricity is very difficult to use it directly. So you need to have some converters to change it to DC. You understand? So powerful. You get me? So there are machines which use DCs directly, but I wouldn't tell you one or whatever. So they have to find some things to reduce the power, because those things, even if the transformer, maybe you have ever heard about a transformer, when it bursts, it can burst like you know what they call a bomb, like a bomb. It can kill people, you know. So that kind of electricity is very what, very high. So somebody is gonna ask you, maybe you're teaching a child and ask you, what about a voltage? You remember we talked about 12V, whatever voltage, and he's gonna ask you those things. What is a voltage? He's gonna say voltage. He's gonna ask you, what is a voltage? Because if you tell me 12 voltage, you have to tell me what is that. Okay, we have the definition here. It says, is the pressure. Voltage is like a pressure. So it has pressure. So you know they can be 24V. This means the pressure here is more powerful than a 12 voltage. The pressure it pushes, you get me? Like I can tell you, like I don't know, maybe pressure, most people know pressure. They measure it like using match. They can see it on water. You get me? How powerful is the water, like in the pipes? You get me? So when you cut on the pipe, some pipes, you see when you go on your tap, sometimes you find the pressure is so low, especially when water is about to go. So you can open, the water is just coming slow. It means okay, let's say that is a 12 volt, right? Pressure is coming slow. But when the pressure, like the water is normal, you can find the tap is the water is coming with a high pressure. So they say voltage is the pressure from an electrical current circuit power. So the in terms, as we try to explain things, is like voltage simply means the pressure. You get me? So that's the pressure. If they say 12V, simply means the pressure it's sitting on 12. So 24, then the pressure is sitting on V on what? On 24. So voltage is pressure. I would say pressure in electric term. You get me? So then they're gonna ask you, another question is gonna be, what does watts mean? This is WATTS. Yes. Those they come usually on electric, I think, lamps. Yeah, if I'm not mistaken, they always write 60 watts. You understand all those things? You get me? So so a person is gonna ask you that question, especially when you're teaching high school kids. They're gonna ask you about that. Even if you don't know much about electricity like me, you can get the basics and know what is going on, right? So if somebody asks you what are watts, Okay. Okay, what is just a method of measuring the rate of energy of an appliance. You get me? So that's why they tell you this, you're gonna see electric bulbs. Electric bulbs, one is gonna have 60 watts, they write it like this, and another one's gonna have maybe 100. Okay, WT. So if they tell you that, what does that mean? It's gonna say they say it's a method of measuring the rate of energy of an appliance, right? So those are amps. So I think, let me try to see if, I don't know if I have one. I was gonna bring you one, then I show you. Let me try to see if I can get one. Yeah, guys, we got one. This is super good. That's why they're gonna tell you that. I wanted to show you something. They always write. You can see 11 watts. So if you find another one, this is an energy saving light. There are those which says 100 W. Those who say which says 60. You understand all that? You get me? So so you can see also it shows the voltage here, 230 voltage, understand? So it means it can hold that. So 50 Hz, you remember we explained that, right? So guys, I think that's the basic, those are the basics I can give you. But electricity, just know, is okay. There's another last question which they asked, what is who's safe between DC and AC? Although people say here, like, and they say DC, direct current, it doesn't mean it's very dangerous because it's direct. AC, okay, I would say the AC is more dangerous than DC. So you don't play on DC, on AC. And I'm saying you should. I'm not saying you should play with DC. I'm saying AC is very dangerous because that kind of electricity is very powerful. You get me? So since it's powerful, it's not even safer to play with it. You get me? So major people who do electricity or who are working for those electric companies and stuff, so they don't have what, they are the ones who knows how to, deal with DC. So if a person don't just climb the pole and want to connect something from there to this side of your place, maybe you know those people who wants to sometimes go to the poles and connect electricity and stuff. So that thing is done by professionals. That's why in your house there is a circuit breakers, there are switches, there are all those things. Those are measures to help you not to be in danger in case of anything if it goes wrong. So those are controllers, those are monitors. They monitor the electricity. Whatever something happened, like in the house, there's a what they call circuit breakers. Whatever happens on electricity, so what happens? It triggers it off. So it switches off to save the devices which are connected in the house, and also to save lives of people so that it doesn't kill them. You get me? So that's what I'm saying. We say AC is typically used for what? For longer distances transmission, long distance transmission and higher power, while DC is used for low power items. You understand? So that's why they say this is more powerful, because it's typically used for long distance transmission and high power, while DC is used for low power items. So that's why this, you saw this cell phone. I had a cell phone here, so that's why I see this cell phone. So this charger is gonna convert your DC to AC from the wall. You get me? So otherwise we're gonna connect these without this device, we're gonna connect this cable straight into whatever. So it could burn, the cell phone could burn. You cannot charge it straight. You get me? So this charger helps us to convert the electricity and measure what the amount of electricity it should take in. This cell phone, you cannot connect two cables and put it in your wall switch or wall plug to charge it. It will never charge. It's gonna burst. It's gonna burn anyway. So AC has more power. So that's why this cable, you can see this end, it cannot connect to the AC, to the DC. You get me? So this cable transport AC watt power. This cable is so small, so the thicker the cable, the more power it can carry or transport. You get me? So the lighter the cable, the less power it can take. So this can only take DC. Once you put it on AC, it's gonna burn. So the heat is gonna come and it melts this, then it catches fire, then it burns the entire house or anything. So never connect these small cables. If you're using DC, you can see cables are they are labeled. You get me? They will tell you how thick it is and how powerful it is. There's a cable you use to connect a stove, electric stove. It's not the same cable you're gonna use to connect to your TV. You understand? Electric stove, those 4-plate, it's gonna be like this. Very, very big, high level stuff. They're like that. And this time on this side, on the side, you can find that it has an oven somewhere here. You get me? So this is something big, so it chows a lot of electricity, this thing. So you cannot use smaller cables like this. This cable cannot connect here. Once you put it here, it's gonna burn. And these things, they connect directly to the walls. You get me? So, and in most cases, you find that some of them, they don't even have much of converters which converts electricity and stuff. I even suspect that these big stuff they use, I don't know, but I think they use AC, some of them, I believe so, because they take a lot of power. Understand? So that's what I was trying to say about when you're connecting electricity, you cannot connect any power, any wire to any electricity. So these can work for DC, cell phones, whatever, all those things, small things to connect into whatever. But if it comes to electricity, like super serious stuff, you cannot connect a cable like this. You can see the car radio stuff. I was connecting one cable here. The car radio and speakers and stuff like that, they have also their own cables, you get me? But also there is a thickness and whatever. So cables goes based on how much electricity is gonna give you or you're gonna get. You get me? So, and I think we about to do what to conclude our video. Now you know that DC is direct current and AC is alternating current, so it moves both sides. DC goes just one way, you understand, one direction. AC moved into both directions. So but then the topic kept on growing and growing, and we touched on some things, you get me? So if we made some mistakes here, please try to correct us. And if you want us to do some videos, more videos about electricity, please tell us. Thanks for watching. See you in the next video. This is Azanio Tutorials. Don't forget to subscribe. Don't forget to share our stuff. Don't forget to click that bell button so that whenever we upload a video, you're gonna get the notification. See you in the next video. Thanks for watching.